Hello, everyone. Welcome to the GVIS Lab Ask Me Anything Live Q&A. This is a very unique event because it's something that we've never really done before, but we did want to have the opportunity to have a more casual conversation with people who are interested in GVIS Lab and what we do here. So to get started, I just want to talk about a little bit about what we will be doing today. So first we'll have introductions, and then we'll jump over to the history of the GVIS Lab. After that, we will share some of the visualizations that we do at the GVIS Lab. Someone will give a little overview of what's going on with GVIS internships and session projects. Then we will have a live VR demo done by Paul Catalano. And then we'll jump right over to the Q&A session. So before we jump into the presentation, we will definitely start with some introductions. So to start off, we could have Paul introduce himself.
Hi there, my name is Paul Catalano. I'm an application developer, and I've been developing scientific visualizations and VR applications in the GVIS for over 20 years now.
Nice, nice. Then we'll jump over to Jay.
Hi, my name is Jay Horowitz. I'm currently retired, but I worked at NASA from '85 to 2012, and was there for a good hunk of the GVIS Lab's fun days.
Fun days, love that. Okay, jump over to Rich.
Hi, I'm Rich Rinehart, and I joined Jay at all those fun days, except I'm still around, so that's it.
And they're still fun.
Yeah, they are still fun.
Love it. Next we'll have Katie.
Hi everyone, my name is Katie Schaefer, and I'm a recent graduate from the Cleveland Institute of Art, where I got my Bachelor's of Fine Arts in Animation, and I just wrapped up my third animation with the NASA GVIS department just a few weeks ago.
Nice, nice. Hi everyone, my name is Kelci Mensah. I am a current junior at Rutgers University studying computer science and cognitive science. I've been with the GVIS Lab for exactly a year actually, so it's been fun and I've really loved it so far. And then next, if we could have Herb.
My name is Herb Schilling, and I'm the team lead for the Scientific Computing and Visualization team. I was lucky enough to be Jay's successor to help run the GVIS Lab. And I wanted to mention kind of where the GVIS Lab sits within NASA. So the GVIS Lab is part of the Scientific Computing and Visualization team. And then the Scientific Computing and Visualization team is part of the Information and Applications Division, which is part of the Office of the Chief Information Officer, which is part of the NASA Glenn Research Center, which is part of NASA. So that's the hierarchy down to our lab.
Yep. If we could have the current interns introduce themselves, starting with Brianna.
Hi, everyone. My name is Brianna. I'm a third-year student in New York Institute of Tech, studying aerospace engineering and mechanical engineering, and I'll be a future intern for this fall as a 3D modeler. Very excited to see you guys. Happy to be on the call.
Hi, I'm Cram. So I'm studying games, interactive media, and mobile technology at Boise State University. And I'll be interning as a XR simulation development intern, working on some virtual reality stuff.
GVIS, which stands for graphics and visualization, but really was more of a pun on gee whiz, was established around 1990 when the science and research world was just getting started with working with supercomputers, and graphics technology was going by leaps and bounds. And the lab needed some sort of a focused facility for providing technology that was just something you couldn't put on everybody's desk, but still the lab needed. And so we created the lab and had a great team doing it. This is what the room looked like in 2004 when the lab was already about 10 or 12 years old. We had a broadcast video editing capability because researchers needed to take VHS tapes to show their work at conferences. On the far right, you see that the videotapes had lousy resolution. It was NTSC 640 by 480 and not even digital. So we needed some higher end technology, and we were the first people in Cleveland to have a full HD TV recording system. We also had a variety of 3D projection systems and all sorts of other tools. This is just one of the rooms. The other room actually had a treadmill and some VR equipment. What's interesting is literally everything in this room is not only obsolete, but can be done by your phone a lot better. Even though the main purpose of the lab was to provide the researchers with the ability to enhance their research and understand it better through visualization, the fact that we produced a lot of pictures and had a lot of very good demonstration equipment meant that we did an awful lot of outreach and promoting of NASA's programs. A couple of the projects that the GVIS Lab worked on, and you'll hear some more about that, was we created a flight simulator that simulated the Wright brothers plane to celebrate the 100th anniversary of flight. On the left, Gene Kranz and James Lovell from Apollo 13. If you young guys out there don't know who they are, go watch the movie Apollo 13. That shows them trying to fly the Wright brothers plane. And we also produced an awful lot of little doodads and handouts for everything from the air show to technical conferences. And these little 3D viewers showed a lot of the research that our team was doing, and it was a good handout. There's the namesake of the center, John Glenn, looking through some pictures. Actually, I think those were pictures we took of him and his wife, but still, he was one of the VIP visitors. But the visitors we had the most fun with were the large number of school troops tours that came through the lab. Because at that time, this kind of technology was unique. Most universities didn't have the kind of equipment that we did. And so it was an awful lot of fun, and we were an open facility to let not just universities and researchers through, but also school kids and senior citizen centers. Furthermore, it was an outgrowth of NASA that's tax supported, and it was a good way to get the public to understand what we did at NASA Glenn Research Center, which was actually Lassa Lewis Research Center, I think, at the time. We got involved with some interesting projects. Like I said, we created a Wright brothers simulator, and then the people in the outreach and education department actually built sort of a model of how the Wright brothers laid down on the airplane to fly it. So that girl is controlling a controller while looking at a large screen showing the simulator. An interesting 3D GVIS Lab project. When I said that one of the rooms in the GVIS Lab had a treadmill, it did, and it was to support a project that we did in cooperation with the Cleveland Clinic that was concerned with when astronauts are in microgravity or zero gravity for long space trips, will they lose a sense of where their body parts are, how their legs move in relation to other parts of their body? Did they get dizzy? And so they created a treadmill in which they were able to monitor where the eye was looking and doing all sorts of other things. And that was an interactive virtual reality screen, and she was wearing 3D glasses. But that was all another project that the GVIS Lab created.
So in the earlier days of graphics and visualization, we've always been focused on stereo or 3D viewing. And this was before Oculus Rifts and all these nice 3D movies and things like that are out now. So there was a couple ways to do it, but one of the ways that large universities and government agencies would do is they'd create these caves, and we're looking at one right now. So it's actually a little room where all the walls in the room, or as many as you can afford, were projection screens. So you would go inside there, you could put on 3D glasses, and you'd have kind of a group submersive experience. And we're still doing that. They've kind of died out, and now they're kind of rebounding and coming back. This is a second one that we just installed recently, and it has snotty 4K projectors and all kinds of things that we never dreamt about in the early days.
This is just an example here of one of the many kinds of applications we develop. Our customer wanted us to show off the remodeled lobby of one of our buildings that houses two of our wind tunnels. And there's two screenshots here. This is actually a WebGL demo. You can visit the website listed below and walk around this facility, not in VR, but a virtual recreation of it. Here is an example of some work that one of our interns, Alex, did, and this is a visualization of a concept electric aircraft. And he took the model in and did some work on it, and actually made it so that you could both fly around the plane and fly the plane itself. So you could fly over a section of Cleveland in this concept aircraft.
Okay, so here's a great look at some of the VR interactive environments created by interns within the GVIS department. This one is an in-depth look at the W7 facility located on the Glenn Research Center's campus. And this is the rotating compressor testing facility, and I was the intern tasked with 3D modeling the environment. And in these images, you can see the very early stages of the environment with no textures applied to most of the models. And in this slide, you can see the finished 3D modeled environment with more accurate renders of the lighting and the textures. And at this point, the project was handed off to another intern, Alex, the one that created some of the stuff in the previous slides. And he was tasked with incorporating it into like a VR environment, so that way the user could walk around and actually interact within it. This is his, like, actually within the VR program. So this is what Alex had like as his previous project in his internship, and this shows like the W7 facility in the VR environment. And then this project is the most recent project I worked on, and I was tasked with creating a multimedia animation to educate the public on space communication. And on this side, you can see a few of the renders of the MRO satellite, also known as the Mars Reconnaissance Orbiter. And I created it for the animation. You can see like the finished animation, and this is just one example of like the various artistic methods used in creating the projects within the GVIS department. A really cool aspect about this project as well is that you know that your work is going to be used in some way, such as being shown at events such as this, or even up on NASA's official website. So yeah.
One of the reasons for our existence at all was to visualize scientific data. And we're still doing that. And that's kind of our bread and butter to some regards. But what you're looking at here is a cryogenic tank storage, something that you might use on a trip to Mars, say, with storing hydrogen. And we would take results from computer codes that would run literally for weeks and months on some of the world's top computers. And we have just gobs of data, and we turn it into something like this. This is actually an animation in real life. And we drop it into our cave, and we twist and turn and slice and poke our head into it and do all kinds of interesting things.
We have interns now spring, summer, and fall, usually involved with the GVIS Lab of different kinds of internships. So we do 3D modeling and XR developers, and also always have one that does STEM outreach. And we've got students that go from high school. So you see up at the top, we've been working with a local high school for many years. There's when we had a group of 6 of them. And then the bottom is a group of 4 that we had in spring of 2020, I guess was. All the way from high school through, we've had some PhD students. So projects, the one on the upper left, we've had, Katie already mentioned some of the 3D modeling she's done, but we've had other interns do modeling of drones as part of NASA's urban air mobility projects. We always have a social media person, like Kelci was for a year, doing tweeting and things like that. We do a lot of STEM outreach, not only in terms of internships and things like that, but we go to schools and libraries and air shows and museums and all kinds of things. And we show our GVIS things, but we also teach students about computers and robotics and all kinds of different things. And in the lower left, we had an awesome high school summer intern. She made a really nice video of kind of geared towards younger students to explain how the GVIS Lab works and things like that. Like the air show. So the one on the top right is when we go to the air show, we have a big NASA tent and we have thousands of people flow through and we show them lots of different GVIS demos.
So my main job is an application developer, and I sometimes get asked, what is the process for making one of these visualizations? What does that look like? So I wanted to talk real briefly about kind of what the workflow is for taking something from the real world and making it virtual. It all starts with a request or a proposal. One of our scientists, one of our researchers wants to visualize something, whether it's science or a project they're working on or a facility, et cetera. And we figured out how to do it. And one of the big questions we ask is what story needs to be told? What do we want to get across? So you got to start with planning. We spent a lot of time gathering resources, so 3D models from our researchers, blueprints, diagrams, videos. We take a lot of reference photos whenever we can get our hands on to use as a reference for our visualization. And then we have to spend a lot of time learning as much as we can about what it is that we're going to visualize. Recently I had to do visualization about ion engines, which is not, I'm a computer programmer, I'm not a astrophysicist, so I had sort of took a crash course on how those engines work in order to develop a visualization. And then we develop a basic outline, and storyboarding can be part of that. On the right, you can see an example of a storyboard I did for a project with my chicken scratch and all that. And a storyboard might just be some diagrams on a side piece of paper I have, or a bullet list or something. Really just trying to get down what the ideas are going to be, so that we can build off of that. And then sometimes we have to write an actual script for it. What does the narration look like if we need to include additional information? So once we get an idea of what we want to do, then we have to prepare all of our assets. So this means if our researchers have CAD models of whether it's a part of an engine or part of a facility, we'll have to convert that into something that we can use, a more useful format for us. A lot of times we're creating 3D models from scratch, as Katie was showing earlier, and we rely on, again, references, blueprints, etc. And then, if you create a 3D model, you also have to texture it. A texture is, what we refer to the surface of a model that makes it look real. A lot of times we have to animate. And then sometimes we record and create audio, whether or not that's or whether that's sound from a facility or that's the narration that we put on top of it. So once we start getting these assets together, then they have to get all assembled and connected with code. So we take our 3D models, our sound files, textures, etc. We pull them into a development environment. I happen to use a tool called Unity, which is a 3D gaming engine, which works really great for our purposes. And got to tweak all these settings until they're right, because you may produce content in one tool and you bring it into another tool, and you have to do some massaging there. All of these assets get assembled into what you might call a scene, or if you were thinking of like a video game, a level or a map. And then more tweaking, there's lots and lots of tweaking going on. You'll add additional visual touches like particle effects. Lighting is a big one. You need to kind of figure out how you want to light this virtual environment. So either you get across a mood or you're getting across a scene, like you want to make it look real. And then it doesn't do anything if it has no programming underneath it. So I'm a computer programmer, and C# is the language I currently use. That's the language that Unity uses. And that's the glue that sort of ties all the assets together, what gives you the functionality in the application. And then finally, we build out for the device, whether it's a VR device, a headset or an AR headset, or a standalone or a web browser. And our tool Unity provides that. It essentially compiles everything into the executable. This is a sort of visualization of that kind of flow. So on a project I worked on, I had a reference photo. I went over and took a picture of the outside of this building, and then I modeled it. In this case, it was modeled in a tool called SketchUp. And the first shot you see with no textures, and then I added textures to it, and those textures come from a variety of sources. There are different tools that allow you to texture models. And then those get imported into Unity and put in a scene, and all sorts of other things like lights and cameras are added. And then when you create the code and put everything together, you build out your final product. And so you can see we go from a reference photo on the far left there to the final result on the far right. And again, Katie showed an example of that earlier with her models that were untextured and then textured. All right, can everyone hear me okay?
Yeah.
Excellent. And I got to find my hands here. I left them on the table.
Of course, happens all the time.
All right, so I am currently wearing a VR headset, so what I'm seeing is actually in virtual reality. Unfortunately, all I can share with you is just sort of a 2D view. But trust me, it looks very real, and I'm not just saying that because I'm the one that worked on it. So I have in front of me my virtual hands on my controllers that let me interact with this environment. And I am standing in the hallway outside of one of our facilities, W1A, NASA Glenn here. And this is a visualization that shows off the facility and it shows off the work being done there. So I'm going to sort of navigate around here. And we have a virtual guide who's standing back here. As I walk around the facility, he's going to pop up and tell me some things. And I recorded the audio, so I hear myself talk to myself all the time, which is an interesting experience. So I'm going to move on here and walk in the door. And one of the things that's really cool about virtual reality, and it's not going to come across in the screen share here, is that since this is stereoscopic, I get a real sense of scale. This is a very large room, and I feel like I'm standing in a large room being dwarfed by this machinery in front of me. And that's one of the cool things about VR is it gives you a sense of place. So I'm going to walk around here and show you, as we move to the side here, and that's going to helpfully animate in place. This is a large test rig here, and in fact, if I walk up to it, so essentially what we have here is in the center, we have a test article, which is a part of an engine. And this big piece here, if I actually go around the back, there is a large turbine basically that runs the front. When you go back around the front, this spins the engine, the test engine inside there. And in order to get the air flow through it, there are, let's see, up on the ceiling, there are big vents. And they open those vents and air is drawn in into the room. This big blue plenum here mates to the front here. And if I go around to the front, air actually comes in through the room and passes through this here. It's a little hard to tell in this visualization, but this is a large array of what they call flow straighteners to straighten the flow of the air. So the air pulls in here, gets as straight as it can, so they don't have a lot of eddies and stuff in the intake air, and it goes through the engine and then back out through the roof, essentially. So let's turn around here. And I have these virtual hands because in this environment, I can actually interact with some things. So for example, if I wanted to reach down and look at a flyer about the facility I'm in, we did a pretty decent job of recreating that, I think, where I could learn more about the facility and advertise the GVIS Lab. This is us. Turn back around here again. Perhaps more interestingly for this particular visualization, so if I go over to this table here, the engine research they are doing or that we're visualizing here has to do with studying the effects of flow inside of this engine and the casing around the outside. Normally it's like this, it's flat, it's smooth. And these are a bunch of different designs for testing in there. For ways to improve engine efficiency by adding grooves basically to the casing. And so in VR, I can just pick these up and kind of take a look at these different design elements. I can even go over, if I wander over here, if I open up this cabinet here, I can actually see these is a long array of probes. These probes are used, as I turn around here, in the test cell. You can see there's these kind of mechanisms up on the top. They insert the probes there, and that's how they measure the results of the test, like what's going on inside the engine. So I wander my way back around here. We actually have a video on this monitor here, and I'm not going to play the whole thing, but if I start the video here, I can stand in virtual reality watching a 2D screen, but you can see like that's what the facility actually looks like. I think I heard somebody comment earlier about that our VR version is a little bit more tidy because we don't have as many cabinets and things like that. If I come over here, I'm actually going to climb up this here to get a better look here. So now I can look in and I can actually see the engine here, and I can see the blade rows and then the stators on the back there. But I think I want a closer view. So I'm going to come back down. If I go into this area here and interact. All right, now I have been shrunk down 50 times my size. I am inside of this engine. You can tell that by this giant hologram here who's telling me all sorts of interesting things. So I'm now sort of in the engine as flow is going through it. We have slowed down time. The rotors would be going much faster than this. And these green arrows represent airflow. So the air is coming in from back, but would be behind me and going through the engine. And normally this would be completely closed. We have the one side open so the hologram can still talk to us. And what we're seeing here is a number of vortices forming along these blade rows. And what happens is because of the interaction of the blade through the intake air, it develops these vortices. And these vortices are essentially inefficiencies. And they intend to build up because you see this one trails off over here and sort of hits the other blade row. And that causes it to form another vortice and it goes all the way around. So that causes an inefficiency. And you'll notice we have this kind of smooth casing over our blade row. But if we switch on a curved, slotted casing here, what happens is some of the flow that is going through here actually recirculates. And that helps to address, or at least that's the intention, to address some of these inefficiencies by causing some of this flow coming off of the end of the blade row to recirculate back into it. If I flip back and forth, you can actually see, this when we have a smooth casing here, the flow, the vortices sort of travel downstream to the other blade row. And when I turn that back on, it actually changes the where that flow forms. The vortices are shorter and they point more downstream, which causes less vortices to be developed on the other blade rows. Okay, so I'm gonna hop back out here. And that's pretty much it for this. I will stay in VR for a second. Kelci, if there's any questions.
Mostly, I just wanted to applaud. That was awesome. Great job, Paul. That was really
thank you.
Fantastic.
It actually worked amazingly.
Okay, so now that everyone's here, we can go right ahead and start the Q&A session. I did see a comment or a question from Bill earlier, so we can start with that one. Do you create any models with photogrammetry? I'll go for it.
So we have played around with it a little. We have not necessarily used photogrammetry, but we've used LiDAR, which, a similar idea. We have imported some LiDAR data sets and visualized them in our cave. And I think we've done it in a VR headset as well. And there are processes and techniques for going from something like LiDAR or from photogrammetry into creating 3D models, like pipelines for that. We haven't done a lot with that, but it's a good technique for taking a real like facility and getting a 3D model out of that in a way that might be easier than trying to recreate it from just photos if you don't have like blueprints or anything like that.
Right.
I do know that while I was there were some wind tunnel facilities that were going to be rehabbed, and they got out the original blueprints from when the facility was built and found out that the actual dimensions of quite a bit of the wind tunnels didn't match the blueprints at all because they made modifications and things throughout time. So they needed to remeasure a lot of those facilities and used all sorts of laser techniques to model the insides of all of the facilities at NASA Glenn to replace the obsolete and incorrect blueprints. So a lot of those would be available for future modelers if they remember where they put them.
Herb, did you want to follow up?
No, actually, Jay said pretty much the same thing that I was going to say. After you left, they did even some more of that for the exact reasons you mentioned, because the as built versus as designed is not the same anymore. And just throwing out one of the coolest things that we ever did, not that there was actually any use for it really, but it was really fun. And Paul mentioned putting some of these in the cave. We had a scan of one of the mission controls. I forgot which one it was, actually down at Johnson Space Center. And they used some kind of LiDAR scan, and it scanned everything, cups of coffee on the desks and crumpled paper underneath the desks and things like that. So it was a snapshot in time. There were no people there, but it was a snapshot in time of what the mission control looked like. And so it was kind of historically preserved forever in these LiDAR scans, and you could walk around it in our cave. It was really fun.
Thanks. Okay, so I would go through the Q&A box, but first, Yoji has a question relating to what you just showed us, Paul. Yoji's asking, was that in Unity or Unreal, and which do you prefer?
To answer the question, that was done in Unity, and I will say I prefer. I can't even say that I prefer Unity. My experience is in Unity. I don't have a lot of experience in Unreal, and we use Unity a lot in our lab only for historic reasons. It was the however many years ago I started using it. It was the kind of the only useful choice for us at the time because of licensing and yada yada. And Unity supported VR very, very early on. So that being said, there are pluses and minuses to both of them, and honestly, they're both fine for developing. And I think that Unity has an easier learning curve, and there's a lot of resources for it out there compared to Unreal. But I don't have a lot of experience with Unreal, so I'm not 100% sure on that. But.
Thanks. Okay, next question is from Mark. Mark asked, when 3D modeling, are you taking dimensions straight from the blueprints?
So I'll go ahead and chime in here. Yes. So if we have blueprints available and have modeled from them, which we have done for some projects, whenever possible, we take the measurements from them or do measurements, derive measurements from them. I'm not going to say we don't often have blueprints. So sometimes we're going off of CAD, which someone has already developed from measurements. Sometimes we're doing it off of photos and other, like hand measurements, like going over and measuring the diameter of a bell mouth or something like that. And I was going to say, with the stuff like that Katie worked on, she was provided essentially CAD models that were developed that as far as I know, came from either measurements taken in the facility or from the actual parts that they were made of, but I don't know the source of this.
That's a great segue. Let's ask Katie. Katie, how does that work out for you?
Yeah, so specifically for the W7 environment, I relied solely on the reference. I had the very unique experience of never being on site for any of my internships, so I had to rely solely onto the reference because I've never been able to go into the facility, unfortunately. So it was definitely different, and I had to kind of assume or look at a lot of things and judge it the best I could. And they did provide a lot of different angles within the video they sent me. So I was able to just kind of measure and pinpoint and just kind of use the general knowledge of the sizing for most of the things and kind of went with that. But basically, yeah, reference anything that I could possibly get to make things more accurate. Was definitely very helpful in getting that started. But yeah, I just relied solely on reference for most of it. Awesome.
Back to Paul.
I was just going to chime in. One of the funny things about trying to model something from reality, you take as many reference photos or measurements as you think, and then you go down to model it and you realize I have no idea how big whatever this thing is, right? You didn't take the measurement. And so sometimes you're doing inferences based on, well, I know how long this wall is, so I'll do this. But one of the ones that ends up being handy on numerous occasions, at least to get something that's close, is cinder blocks are a relatively standard size. I think they are a standard size in the United States. So a lot of times I would look at a picture of a room and count the number of cinder blocks, and I would know the approximate length and height of that thing, because otherwise I didn't have a measurement for it, and I didn't have a tape measure long enough when I was over there to even get that measurement. And you can get pretty close with that, and then kind of dial it in later if you get the real numbers.
So lots of estimation guesswork kind of.
Right, yeah. And in a recent one, I wanted to model, we have signs in front of all of our buildings, and I don't know what the measurements of these signs were because I didn't take them while we were on the lab, and we haven't been on the lab, but we had a photograph next to the sign in front of our building, and I know how tall I am, so I just used that as a reference. I'm I'm this tall and the sign is this high on me, so it's about that tall. And it gets you close enough for something like that where it's aesthetic, where the true measurements aren't as important.
Okay, awesome. Thanks. So Oliver is asking, are your headset-based VR applications mostly single user, or do you have multi-user collaborative frameworks?
So currently, the applications we developed from up to this point have been single user. That being said, I would like to, in the future, and maybe migrate some of the ones we have to multi-user. Up until now, we basically just didn't have a framework to do that. Now there are some good frameworks out there for Unity in particular that make it a lot easier for doing that. We've done some stuff with multi-user. It tends to be, in the past, it was kind of cumbersome, and it's less so now.
Okay, cool. Brian's asking, what other projects at NASA outside of GVIS have AR, VR been used in, and what capacity?
Maybe the most famous AR application that I know of that NASA has done is this thing called On-Site. It's been so long since we've run it because we haven't been able to run it during COVID and everything, but it's a augmented reality HoloLens application that JPL actually used for mission planning of the rover missions and then analyzing the data that comes back from that. So multiple researchers could put on the headset, or engineers, drivers, rover drivers, things like that. And it would be just like they were on Mars and see the real data. And they can try to figure out their plan for the day using that. And then after they got the data, then geologists could put the headsets on and they could walk around as if they're really on Mars. And they call that virtual geology. We got a version of it that was for public release, and well, you couldn't really interact with it much, but you could put the headset on and you could walk around a certain patch of Mars. Well, I mean, for a long time, and Jay knows this too, they've been using VR for training astronauts, probably 20 years at Johnson Space Center, especially for like EVAs, spacewalks, things like that. So.
Okay, cool. So now we're going to switch up the questions a little bit and head over to the interns and ask them some stuff. For Brianna, at least, what are some of the skills and experiences that have landed you in this position that you're in? And also, are you excited?
I am very excited. Thank you for asking. That's a very good question. I guess one thing I could offer for future interns who are interested, show everybody what you're crazy about. I feel like with 3D modeling, portfolio, showing off your skill sets, texturing, modeling, wriggling, knowing that you have the fundamentals down and that you're able to do it. And most of all, I think a really good skill for an intern here to have is to be determined, be motivated, and be ready to inspire others. Those are 3 big things.
Awesome. Okay, and so we're going to go over to Herb and maybe the rest of the full-time GVIS team. So what does a typical work from home day look like for you guys now that you're still GVIS Lab, but also at home?
I don't even know if I want to answer that because lately a lot of our things have been not very, very not fun, more related to contract stuff and budget stuff and things. But I shouldn't complain because I know other people in other industries would say, yeah, we have to do that too, but you get to do it at NASA. And it's totally true. So, but well, I mean, even doing this thing is fun. So, but typical day, yeah, lots of meetings, more meetings than ever. Talking to some customers sometimes, and we have lots of interns. So they just started this week. So I spent a lot of time with the interns working on the outreach, or we do a lot of data science, data work lately too. So I spent a lot of time with interns there. So.
Awesome.
We planned ahead as well. So GVIS, we kind of joke about it, but it's distributed. It's all around town, all of our assets that we have, our head-mounted displays and all our gizmos. So it keeps us occupied.
True. And then back to Rich real quick. Bill's asking, does Unity also run in the cave?
Well, Bill, we would like you to fly here. Is this Bill Sherman?
Yes, it is.
We would like you to come up, and yes, we can run it in the cave, but we would love for you to visit and to make it even better. And pair of you.
Okay, so Mark's asking, does GSE have any current or upcoming HoloLens projects?
I can answer for one on that. Well, it's not current, but upcoming. And at least we hope. A big thing that NASA's getting into is digital twins, if you know what that concept is. So there's a physical object, like for us, it would be a concept plane. And then there would be an equivalent digital model of that. And they'd be talking to each other basically through sensors one way and things. I could spend a lot of time on that, but one of the things that they want to do with that is be able to visualize some of that data in the place of the physical model. So they'd like to go to a test facility where they have one of these concept vehicle models, and it's gathering data, and somebody wants to be able to put the HoloLens headset on and see the data being captured in the context of the actual physical device.
Awesome. Okay, we're going to jump over to some pre-asked questions from the form, the Google form. Kushid is asking, what are some of the programs that NASA has created so far with the VisBox cave system?
What are some of the programs? Well, we did a urban air mobility application that was big in it, flying, an urban taxi around, and the cryogenic tank that you saw earlier on, that was fun. I think what's fun is to take analytical data, and the scientists are used to seeing it on a flat screen, and to bring it into life and let them stick their head in things and look for areas that they can't see in 2D. So that's and almost all of our applications that we have done in Unity, we can get them to run in the cave, and many of them that we do.
Awesome. Okay, so talking about development, this is a two-person question, both Katie and Caleb. Could you talk about some of the issues that might come up when you're developing something or 3D modeling something, especially for mobile and other devices specifically? I don't know who wants to go first, but. Okay, Katie, go first, and then we'll hop over to Caleb.
Yeah, I'll just jump in. One of probably the biggest issues that I've run into, like 3D modeling wise, well, I use Maya a lot. Maya is like my primary 3D modeling program, and it does crash quite often, unfortunately. So you always have to just make sure that you save your stuff. But then also the hardest part within the 3D modeling process is probably just making sure the UVs are right, especially on things that are highly textured or have a lot of texture to them, and you want to make them as realistic as possible. You want to make sure that the model and the entire file can handle it and its size. So you just have to make sure the UV, the mesh, everything is just modeled correctly, and every vertice is just in the right place, and everything just lines up perfectly. But once you get the hang of it, and you get more skill, experience, it's a really fun thing, which is why I think we have a lot of 3D modelers here, because it's such a really fun thing to do, especially see the finished project or the product of it, the fully textured, and seeing it being used is such a great feeling. But yeah, there's quite a few road bumps in the beginning, especially when you're starting out to learn it. But once you get through it, it's a smooth ride. So
awesome. Caleb, anything else to add?
Yeah, I mean, you did a great job covering up the covering how the art is kind of handled. I guess from more of a programming perspective, especially when you're building to mobile devices, optimization is huge. It's really easy to not pay attention to how many things you're running at once and make it not run very well, especially when you're trying to make it run on say the Quest 2 or something like that. Because at the end of the day, these mobile VR headsets, they're basically just a phone strapped to your face. They're powerful, but that's all they really are. And so, you have to do a lot of optimization, and that goes all the way back to the art, where it's you gotta be okay, how many polygons can we have in each of our objects and stuff? And there's a lot of things to track there and ways to optimize. And I feel the hardest thing is that there's no one answer. There's a lot of ways you can go about it. You can make your art lightweight, or you could use heavyweight art and just only load parts of it at a time. There's a lot of possibilities of ways you can do that. And so, yeah, I'd say the biggest challenge is just deciding how you want to fix it and how you want to tackle it. And then once you do, just keeping track of that.
Awesome, thanks. So talking about some of these issues, Jay, did you ever have any of these issues back in the 80s and 90s and early 2000s?
A question earlier about how interns can prepare for an experience at NASA or the internships, and one of the sort of corny answers I give when high school students say, "What should I learn? What language should I learn? The most important thing to learn is how to learn." Literally, all of the tools that we had didn't exist when we first started working at NASA, and all the tools that we had when we started working at NASA don't exist anymore. Right now, for example, Paul is feels quite comfortable with Unity because that's what he got started on. But it's not uncommon for a new application to come up And all of a sudden, everything he learned about Unity, he has to relearn on another program, sort of like learning another musical instrument. So we spent an awful lot of time sitting with manuals in front of us. I guess nowadays it'd be sitting with Google in front of you and just jump in head first and learn to do things. That was true when a lot of the applications that we were working on, even the developers themselves didn't understand all the applications their tools would work with. So for example, we would get a hold of a visualization program or a software program, and we would get it to do something almost with the chewing gum and Scotch tape to get it to do something that wasn't designed to do. And then the developers would come to the lab, or they'd see what we were doing, or actually from other NASA centers, and they'd say, boy, that's a really great idea. And they would modify the software to allow others to do what we were doing as a kludge to be a part of their software. So it was not uncommon to wind up with products and software that didn't do everything that we wanted it to do, or didn't do it right, that we had to learn to work around. And that was quite common.
Yeah. So even talking about that, maybe Rich, you could also help with the answer to this. In terms of like documentation and how to like fix things like that, there was no Google at that point. So you were here from practically the beginning. How did you guys kind of handle that earlier on?
Yeah, like Jay said, it was all manuals. And what's funny now is I still have all these manuals, and you look at them and it's like, my God, I used to rely on this stuff. It's just the one thing now is you could do things so much quicker because it's just a couple keystrokes in and you have a world of information, stuff way past any manual can give you. And it's really something.
Tad and Kathy are asking, are you open to new partnership with general industry?
Yeah, NASA, Glenn, NASA in general is always looking to partner with industry, and they do that quite a bit, and academia too. We haven't really done, maybe Jay knows more or Rich knows more about industry partnership, other than things like the Cleveland Clinic, if you want to call that industry. But lately we've been trying to get things going with Case Western Reserve on a few things. It's always a bit of a struggle to get past all the legal and other issues. Yeah, we're totally open. Yes.
Right, awesome. Brian's asking, has GVIS looked into alternative ideas for locomotion in VR? A, to prevent seasickness. B, with room scale VR, having a VR area larger than a physical area. And then C, for a more intuitive experience. So I think this is probably like a multi-person question. I'm not sure who wants to start off.
I'm surprised other people aren't talking about John Tompkins was on this call. He keeps wanting us to buy one of those Omni treadmills. Is that what they're called? Omni treadmills. But we haven't really done anything with it there. Rich will remember at one point we went to Miami University to look at their lab, and they were doing a lot of redirected walking research. Google it if you want to know what that's about. But it's just the idea of how do you get past that you're trying to walk around in a big space, but physically you're in a small space. And so there's tricks you can do kind of with people's minds in a way to get around that. But, we just saw that. We never really did anything with that. I don't know if anybody else can jump in and talk about some of the other things.
Paul wanted to chime in earlier. Did you still want to chime in?
Yeah, I just second what Herbert said. We've looked at some stuff. This is not quite the same thing, but I know we tried out in the past before standalone VR headsets that weren't tethered to a PC. We were trying out basically we'd wear a PC backpack and wear your headset on that, which allowed you more freedom to move around because you're not tethered. But the problem with that is you're wearing a VR headset, so you can't see where you are. So it was kind of a mixed bag. Now there's standalone headsets and they have pass through. So we've certainly looked at in terms of we're aware of things like little treadmills and whatnot. We haven't really experimented with them too much. Mostly I focus on as the developer, just kind of providing different locomotion methods using with our controllers, like you can teleport around, or you can have preset views, or you can move around like you might in a video game, and kind of trying to offer some solutions that way. Nothing with real physical devices though.
Interestingly enough, that project that we were working on with the Cleveland Clinic and the treadmill, that was a specially designed dual track treadmill. The two treads actually could go at different rates, and that was done to allow the feeling of actually walking around curved paths to be more realistic, where one foot would have a different stride than the other foot. And that was key. The speed of the tracks was actually keyed to the visualization, so that if you were going through a tunnel or over a wall, your feet would get a much better feel for exactly what was happening to each foot independently. And they were tracked with all sorts of sensors. That was some time ago, but that was a much more complex locomotion device than most people had in VR. And we had both the screen. I think we also did that with an HMD, but they had so many other wires and stuff attached to them to monitor them that I think we wound up sticking with the screen rather than an HMD.
So this is also more of a general question. How do you think the development of stuff like that, where movement and just brain tricks and stuff like that, how does that affect the common person in terms of using these devices? Again, and this is like a multi-person question, so.
Yeah, I know I don't have an answer to that one.
That's a good Jay question, because it's all about stereoscopic vision, and it affects people differently, and people's eyes are different distance apart, and there's a lot to it. Bill Sherman on here would attest to some of this as well.
There is, I think there's also an awful lot of very interesting adaptation to what your sense of reality is. I remember when we first got a Nintendo for my 4-year-old, and he was playing Mario Brothers, and every time Mario would jump over something, my son's whole body would jump up. I mean, he adapted to the reality of what was going on the screen. And now when I see my grandkids playing Fortnite, I mean, their body language, they're living in that world. And so I think in many cases, it's not so much a question of creating all the tools to get it to adapt and make it seem more realistic for the person. The person winds up adapting to the reality that's presented to them, and they live in that world. So it's going to be a combination.
Okay. And Paul?
Can I share an anecdote? That's just kind of a side story. I have always been surprised at how easy it is to trick your brain. Most of what we do in GVIS is trickery, right? And we've been doing it for a long time. Whether we have like stereo cards that are two images separated, and you look at them, and when only your left eye can see the left side and the right side can see the right side, your brain goes, hey, it's 3D. And that's how a lot of the stereo stuff works. But in VR, like, you would think that, I need to create a scene that is completely photorealistic and looks just like it in the real world, or it's not believable. And that's not true. Like I had an experience where I was. As a side experience, like I just playing like a game on an Oculus. There's a game out there that is not photorealistic, and like the environments are basically monochrome colors. But after playing it for just a short period of time, like you start to think that the objects are real. So like at one point there's I was ducking behind, like there was like a bar or a bench or whatever. And when I went to stand up again, I reached out with my hand to try to push down on this clearly, computer generated object in front of me, about fell over. And multiple people I've talked to who've done that have done a similar thing. But I was working in the lab one day, and I was working on a project, and I was testing it in VR. And this was kind of early on with our new headsets. And I had developed this little scene, and it was pretty simple, and it wasn't particularly realistic, but I kept putting the headset on and testing a thing and then taking it off and changing something and going back and forth over the course of an hour or more or whatever. And like I said, it wasn't particularly realistic, but when I put the headset on, it reacted and it moved like like it might in the real world. So at one point I didn't realize I had knocked out the tracking cable, basically the USB cable. I put the headset on and I moved my head and nothing moved, and my brain freaked out because all of a sudden this environment that I had expected to react like the real world didn't, and it was incredibly disorienting. And at that point I said, okay, I think I'm done for the day and I need to step out of VR. But I was amazed, and I'm always surprised it doesn't take a lot for you to convince your brain that something is, it just has to pass a couple of tests and your brain goes, okay, I'm willing to accept this as real, even if it doesn't look real.
Okay, actually, to go off of that, Richard asked in the Google form something that's along the same lines in terms of like safety more so. Richard asked, I'm intrigued by the possibility of using augmented reality and 3D visualization to help understand relationships between system design elements, requirements, physical components, data, safety hazard, etc. Do you think this subject would be appropriate for AR 3D visualization, and do you know of any research in the area currently?
NASA has a safety center. It's called the NASA Safety Center. It's actually located in Cleveland, not actually directly on NASA Glenn base, but just right off of it. And we've been talking to people for the past year or two, and they're very, very interested in AR, VR, for one, for doing remote audits and things like that. But the other thing is for training. So that they're definitely interested in doing training for with VR. So we've got these wind tunnels at NASA Glenn, lots of other NASA centers have them too, and people need to be trained on how to use them. So how do you train somebody on something like that affordably? You don't want to fire up a wind tunnel just to train somebody because it costs $10,000 an hour to operate. So if you could create a virtual reality system that's just like it and use that to train people, that would be a huge time saver. And that's a really big thing because right now a lot of operators are retiring and they need people to get trained. So I don't know if that helps, but it's my take.
I mean, I think it does because it really ties in, like you can trick your brain into thinking something, which is what Paul was talking about earlier. And that if that saves a lot of money and time, I think that's a great way to start training people. Yeah. So Nick asked, are there any of these virtual models that I guess that we've talked about already? Are they available for the general public to download, view, or interact with from their homes?
No, it's kind of the bottom line. Unfortunately, we've that Paul and Rich can talk about it too, but yeah, we've talked about some things where the people could download some of the models and the apps and things like that. And there's even been a push by some people at NASA to try to get us and other NASA centers or visualization labs to share our models. But we just never get around to doing some of those things. I mean, there is the NASA 3D website with some NASA models, but it's far from exhaustive.
And Caleb, I saw that your hand was up.
Oh yeah, I was just gonna say, if you have an Oculus Quest or any VR headset, actually, you can play a Mission ISS. It's not specifically related to this, but it's really fun. And if you haven't done it, check it out. It's a pretty well made little experience.
Katie?
Yeah, so I know like the 3D models. I was also like kind of like questioning that too, like just even before like being a NASA intern. But yeah, the website that Herb was talking about is called NASA 3D Resources. And they have a huge list of like anything that you could like really need, and you can like 3D print some of this stuff too. I've never tried that because I don't have a 3D printer, but there's some models that you can just go ahead and like use, and some of them like might have the textures on and everything, but it's like a huge library of stuff that they have. It's not like high res on all of them, but it's still pretty cool, and they offer like a great amount of detail just for you to like print it out and kind of like give to people or something.
Base Alpha. And it's an interactable video game where you're on a crew and you're on the moon and you complete missions together using teamwork and stuff. And you can see that whole physics environment unravel.
Awesome, thanks. And I was just about to ask both you and Katie some more resources in terms of like getting started, because I know that's something that is important for a lot of people in terms of 3D modeling and things like that.
Yeah, in terms of 3D modeling, I guess some resources in order to get started. One big thing I do recommend is familiarizing yourself with the program. taking some time to sit down, whether it be Blender or Maya. I've used a lot of Blender in my time. It's a free open source program available to the public, has a plethora of add-ons you can use to fit your own user experience. And I do recommend official documentation, YouTube tutorials. That's the way to go for 3D modeling. Definitely YouTube tutorials, definitely.
I have to agree with that one.
Yeah, I kind of have to second everything that Brianna said. YouTube tutorials are definitely a big one. There's this really great like team called Flip Normals. They offer like a lot of really cool 3D like tutorials and everything. But also like Blender is free. That's a really cool 3D modeling program. I'm just now starting to get into it. But Maya, any software that basically you can get your hands on, there is a lot of like free tutorials out there. Like ZBrush is a really cool 3D program, and it's getting way more popular. And it's got like a month subscription for free, but you just input your email, so you can kind of like cheat it and like put in a new email like every month or something. But basically, just try to get your hands on as much software as possible that you're interested in. So that way, if you just open it up, familiarize yourself with like the user interface. So that way, you like if you ever do need to know it, you already like looked into it, and you can try to put some things together. But yeah, I would just say try to get into as much as you possibly can. It can't hurt to learn a little bit from like a lot of different programs.
And Brianna had mentioned open source and free, but in terms of like the more official NASA team, how does that work or translate into doing projects where it's like under security, it's under, rules and regulations? How does that work for you guys?
Well, within like the past projects that I worked on, Rich actually for my last one, for like the W7 sent me like this hard drive that's like encrypted, so that way you can keep everything safe. But NASA sends out like laptops that you can work on, so that way like you can't like put a hard drive in it. The security is very high, so like it's really hard for everything to go like to have a VPN. Everything's pretty safe and secure. So just basically trying to get your 3D models like converted or over is probably the biggest thing, is like with the file size now. That's probably the hardest and most difficult part. But yeah, everything's really secure, and for the most part, it's easy to like get things over as long as you like communicate well and everything's like cleared up.
Awesome. And then once again, jumping back to free, in terms of like general costs, is it really expensive to like develop these type of things? Or is it like something simple that anyone can do?
I think it would mostly depend on the situation, but also if you compare, say, making something virtually to making something in real life, the footprint is less, it's a lot cheaper, but you're also able to make more accurate simulations, something that you can control very nicely. So I guess in a sense, it really depends on the situation, but on the whole scale, I'd say the benefits of making something, the cost would be less in the virtual realm, if anything.
Okay. And then earlier, Caleb, you had talked about developing stuff for the Oculus and other headsets. Does that development cost have something to do with anything, or is it just about the same?
Yeah, definitely. I mean, I'll say like with development, I mean, the biggest cost is your time, really. I mean, a lot of these tools are free, from my experience. I mean, like Unity, Unreal Engine, I mean, Blender, a lot of these things are free. And if they aren't free, they give free trials. And there's a ton of resources to learn them. So learning them, oftentimes you can at least get the basics for free. And so I'd say the biggest cost really is your time. So it's just, kind of figuring out like, okay, what do I want to focus on? What do I really need to like, get done first? And that's kind of the hardest thing, is just seeing what's worth it in that regard.
That's very true. I love that. The biggest cost is your time. That's very true. Okay, so jumping back to another development question, Mark asked in the Google form, this is actually directed to Paul specifically, what was VR development like in the 90s? Could you kind of tell us about that?
I don't know, because I was in high school in the 90s, so I wasn't doing any VR development. Although I did start in the 2001 is when I started at Glenn. It's interesting because the hardware, at least in terms of like the form factor for like a VR headset, I did some work early on with a VR headset, and the form factor is similar because obviously you have, you got to have a screen, and you have to have a thing to put on your head. It was just a lot more cumbersome. They were CRTs instead of LCDs, so it was this, and it was probably I don't know what resolution. 240 by 180 or something per eye. It was pretty low. I forget what the original ones were. And it was, you had sort of bulkier tracking and things like that. And there weren't a lot of, the real problem and part of the reason that VR kind of goes up and down is that the hardware was expensive and niche. And so there weren't a lot of tools for developing for it. So there were only a couple of software APIs we could use. And honestly, the graphics languages, because the hardware wasn't as capable as all of these things, right? Like the hardware wasn't as capable as doing as much stuff, so the graphics APIs weren't as sophisticated. Now you fast forward to 2021, and because we have, like a mass market, a number of mass market VR headsets, they're more easy to come by. There are more tool sets. Like I said, Unity supports them out the box, Unreal supports them out, and because video games are the driving force behind consumer graphics, all of these things that are that video games leverage, we use for developing our visualizations. Whereas in 2000 when I started, certainly video games were big, but the graphics technology wasn't where it is today. So.
And then Jay.
Yeah, in the ancient days, the early days. A lot of the capabilities and programming tools were very vendor specific. For example, the company Silicon Graphics would come out with a workstation and capabilities that were unique in the industry for doing 3D modeling and interactivity. And so they had to create ways to program it. And so their OpenGL programming language became the de facto standard, but you had to have their equipment. Eventually, it sort of opened up and became an OpenGL product. Same way with Pixar, when they developed a lot of tools for doing their animation, they had to create all of their own software. And they used a product called RenderMan for doing highly realistic rendering. And everybody wanted to do that. And eventually, that wound up being released to the public, and more labs can do it. Similarly, when the Cave first came out, all of the programming languages and tools for the Cave were developed by the people at the university that developed the Cave. And they had a program called CaveLib. And if you wanted to use a Cave, you programmed in the CaveLib. Interestingly, the hardware developers for Silicon Graphics realized they could make a lot more money instead of selling a couple $130,000 workstations. We can sell a couple $1 million PCs with graphics cards. So the NVIDIA Corporation was actually founded by some people from SGI, Silicon Graphics, that left it. So a lot of the tools that you're seeing now were actually vendor specific or university specific that wound up coming out to the public. Even Blender, I'm sure, copied something from somewhere.
Can't argue with that. And then in terms of like coming from then to now, because Paul did mention the timeline, and it's been at least 20 years. Someone had asked if the introduction of 5G has anything to do with the development, and if that's going to slow anything down, or if that's going to privatize a lot of the tools used.
5G, good.
Oh, Caleb, I offered him up as the person to answer this question, so go for it, Caleb.
Yeah. 5G is pretty great. The big thing is that, like, the biggest thing to think about is that it brings a higher bandwidth to your internet connection, and so that just means you can transfer a lot more data, and you can just do things a lot more quickly, and it opens up a lot of possibilities. And so, I mean, as to what that impacts, I mean, it's almost everything, to be honest. I mean, I know from my experience in development, oftentimes the biggest bottleneck I've run into is a bandwidth limitation. For example, I've worked on a project at Boise State University. It's actually for a NASA Suits challenge, where we're trying to put, like, basically it's like augmented reality software for like a spacesuit. That's like the idea. And we've got a deal where we take the HoloLens and we like map the environment, and then we send the data over, an internet connection, and then we bring in a VR headset, and we can go through that in real time and send notes back and forth. But we have this issue where every time we try to bring texture data over, like all the colors and stuff from the real world, it's just too heavy. It takes way too long to load because of the bandwidth limitations. And 5G is something that, while it might not immediately fix that, given some time, it could actually lead to some solutions there. It just opens up a lot of possibilities. you can start having devices that offload a lot of their functionality to the cloud. So you can do a lot of cloud computing type stuff. In fact, we've actually done that on the project I just talked about. And, we've done things where we look at using like Microsoft's custom vision service from Azure. And that does a lot of like computer vision type stuff for image recognition. And we basically just offload all of the computer vision to that and make them do all the heavy lifting. And then it just tells us what it recognizes. And that makes it so that it's not as heavy on the headset, and you don't have to worry about slowing things down. But yeah, and 5G just kind of enables all of that to run more quickly, so you can run more data over it. Yeah, lots of cool possibilities with it. Very exciting.
Thanks for the answer and the explanation. That really helps. And so actually, Caleb, back to you real quick, because this might be actually the last question. Someone's asking if there's any advice for junior software developers trying to get their foot in the door.
Yeah. I mean, I'd say hands down, the biggest thing is just experiment and play around with stuff. There are so many resources to learn from online. I mean, it's almost painful that I can't do them all. I swear every time I look somewhere, there's some new thing and I'm like, I don't have enough time for this. But it's cool because there's a ton of resources to just learn stuff and try new things. And I mean, oftentimes I'd say the biggest thing is that a lot of people, like, they'll talk about stuff and they'll think about it, but they don't take that step to just like try it. And like oftentimes I learn the most when I just try it. And oftentimes I might not know what I'm doing and I maybe mess up a lot and it might be a rough learning experience, but I learned it. And that's the biggest thing, is just jumping in and trying it out and just, seeing what the limitations are of things and seeing how they work, and honestly just playing around and having fun with it. But yeah, there's a ton of resources online. I mean, YouTube is incredible. I've learned so much from it.
Does anyone else have anything to chime in? Because this might be the last question, just in terms of anything to learn. Sure, Jay.
Yeah, and this is a story about Paul Catalano. When he applied to NASA, he was actually applying for a job, I think, in the business programming group. But part of his application pointed to a website that he had. And on the website, there was a solar system model using OpenGL graphics programming that he had taught himself. And it had absolutely nothing to do with what he was applying to NASA for. But when our team saw on his website, oh, here's somebody that taught himself graphics programming and created an application just for his own amusement, we said, he's not going to the business group. We're going to grab him for our group. And it was worth it. So, yeah, things that you do on your own for your own passion can sometimes pay off.
I can't agree.
You did develop that, Paul, right? I mean, that was you.
Yes. No, I did. Yeah, I was gonna chime in with that because Bree mentioned that earlier about showing your passion, and like in my case, it was I went into computer science in college, and I didn't know what my focus was going to be. And at the time, computer graphics was not necessarily on my radar, and it was certainly less developed than it is now. And like in my senior year, I took a computer graphics course as an elective because I was kind of curious about it. I had always kind of thought like, well, that's for the more artistically inclined or for graphics designers and things like that. And I really enjoyed it. I thought it was great. And so from taking that class from that point until I got my offer at NASA, I was basically spending my free time learning more about computer graphics and kind of developing these things. And so I had this portfolio of these things that I had worked on in my free time of like, here's the things I'm noodling with in graphics because I think it's cool. And that was sort of my foot in the door. And I got incredibly lucky, obviously, but I showed my passion and my willingness to learn, I think. And I think that really helps.
And if I could jump in really quickly, I know we're out of time too, but I hate to single out anybody, but Caleb, Katie, and Bree, all three of them have awesome portfolio sites. And we're really one of the main reasons why we picked them for their internships. So just to follow on what Paul did, same deal. It's the same thing now. So
what I'm getting is update our portfolios. Okay, awesome. Well, we're running out of time, so I will just say thank you to everyone who was able to come and watch us. Also, thank you to the panelists for being able to answer everyone's questions. Just before we go, I did want to share the GVIS accounts, because that's exactly where we will be posting a lot of like content, anything cool that is going to happen in terms of like anything that's going to be going on in the future, and just to like highlight other people as well. That's kind of where we focus all of our attention in terms of social media outreach and engagement. So once again, thank you everyone for coming.